So those that are just joining on the Google Meet, working on the practice test today, make sure that you have a graphing calculator available, whether or not you have your own or you're working on the app. Label your notes. If you didn't print out the practice test, just label it practice test at the top and make sure you number everything. That way when you're studying later, you can pull up the black folder that has the digital copies of worksheets and handouts, and you can look back at it and see what the problem was when you're studying for it. All right, we're ready to go here in class. So I'm going to go ahead and get started. And we have the first problem says use a synthetic process to find p of negative 5 if p of x equals negative x to the third minus 2x squared plus 3x minus 1. Well, we know what the synthetic process looks like. The question is, this is going to make the difference between getting it wrong or right. What number goes out in front? Oh, I see you're giving me the numbers in here. I'm looking for A. What goes out in front? Negative 5 does, exactly. And that's because this is not in the form x minus A. They're saying just put negative 5 into P. Now, we have to check and make sure it's in standard form. Everything's there. Powers are 3, 2, 1, 0, so get those coefficients in here. And complete your synthetic. And you know what? There's only like 7 problems on this test, so go slow. Be extra careful. Bring down your leading coefficient. When you're outside the box, multiply, and then put it inside the box. Inside the box, add. Outside the box, multiply. Inside the box, add. Outside the box, multiply. And inside the box, add. Now, here's another big step. What's the answer? It's just 59. This is not a division problem. This is, hey, if we put negative 5 in here, what do we get? We got 59. And there it is. If it's division, then we have to do remainder constant x squared and work our way around. But this one was just use the synthetic process to find p of negative 5. This one says divide synthetically, so the directions changed, but what we're doing changes just a little bit. So we have x to the third minus 4x squared plus 6x minus 4. We're supposed to divide that by x minus 2. Big step. What goes out in front for A? Yes, 2. Because remember, they're always written as x minus A. If they're in that form, we have to think opposites. Again, you double check. 3, 2, 1, 0. They're all there. Oh, my copy on that smartboard is not very clear. X to the third minus 4x squared plus 6x minus 4. Yep, we got it. So do your synthetically, slowly and carefully. Now let's figure out what our answer is, because it's not just 0. This didn't say just put a number in. It said divide synthetically. So remember, you start over in the right-hand corner. Remainder, constant, x squared, and if there were more numbers, we would keep going, but there aren't. So our answer is x squared minus 2x plus 2. And this one worked out perfectly with no remainder. I wouldn't expect that to happen on a test. More likely than not, you're going to have remainders. So far, so good? Okay. So then it's good that it didn't change gears. We still have another one to do here. X to the fourth minus 4x plus 2 divided by x minus 3. Again, probably the most important step. What goes out in front? Because you know the test writers are going to put a -3 out there too, right? And if it's multiple choice, then that wrong answer will be down there. So yes, 3. And do you notice anything fishy about this one? You do need zeros, yeah. It's in standard form, but we're missing x to the third and x squared. So 1x to the fourth, 0x to the third, 0x squared, -4x, and 2. Again, slowly and carefully, do your synthetic. And this is probably more realistic because it does have a remainder this time. Same set of directions as before. Divide, which means we have to write down our polynomial that we have here. So we've got x cubed plus 3x squared plus 9x plus 23. I don't know that I'm going to have room for my remainder on here. Plus 71 over x minus 3. Got it. So, look at that. 7 or 8 problems on this test, and the first 3 were already synthetic. I mean, most of this test is going to be about synthetic. And that's because we want to use it whenever we can. But we also talked about, when we covered this material, some of them cannot be divided synthetically. Brings us to this one. And the directions say divide using long division because 2x plus 1 is definitely not x minus a. So we don't have a choice. We're going to have to do this one with long division. So we're going to take 2x plus 1 and divide that into 2x cubed plus 9x squared plus 14x plus 5. Just double checking that I wrote it down correctly. Got it. All right, you guys were experts when we did this, but it's been a little while. So tell me what I'm trying to do with my 2x plus 1. Excellent. Match it with that first term, 2x cubed. So this is 2x. What would I have to multiply that by to get it to be 2x cubed? Need an x squared. 2x times x squared will be 2x to the third. That gets us the first term, and that was exactly what we wanted. Because we're going to change that, change those symbols to subtraction, and think about it as adding a negative. So x squared did exactly what it needed to do. I'm going to put it up there as part of my answer. 2x cubed minus 2x cubed is 0. Perfect. That's what we needed. 9x squared minus x squared is 8x squared. Then I bring down the next term. And we start over. Like so. What will we need this time to make it work? Good, a 4 and an x, because we need 8x squared. Again, focus is only on the first term. Get the first term to match. 8x squared plus 4x. Change the signs. It's working, so we're going to put our little 4x up here, plus 4x. 8x squared minus 8x squared is 0. 14x minus 4x is 10x. And bring down the last term. And let's try it. So what do we need this time? A 5. 5 times 2x is 10x. So 10x plus 5. Change the signs. Add, and we're pleasantly surprised here. Not only did that 5 work to get rid of the 10x, but it also worked to get rid of the 5. So we don't have a remainder. Again, on the test, it's more likely you will. But the process is what you have to remember as you go through it. And that is definitely the process that we used. Alrighty, so expect, looking at the practice test, one long division problem, Because again, we don't focus on long division. It's what we have to do when synthetic doesn't work. That's what we have to do. All right, next up. Oh, where's my extend page? There we go. Use the rational root theorem to list all the, there it is, there's the big hint, possibles. Possible rational zeros of f of x. So this was the big fraction. And then figuring out what we have for the big fraction. Because rational, the root word is ratio. Ratios in math mean fractions. So help me out. What number do we focus on for the top? The 2, yeah, it's weird because it starts back here. Good news is 2 doesn't have a lot of integers that divide into it. Plus or minus 1, plus or minus 2. That's it. Here comes the bad news. What number do we have to use for the bottom? 12, and 12 has lots. So, very last number, factors, integer factors go on the top. Very first number, integer factors go on the bottom. Whew. And then we have to figure out what they are. We want to know what they're going to come out to be. So, pick a way to do it. Just stay organized. I think I'm going to go through everything on the bottom with a 1 first. So 1 over 1 will be 1. 1 over 2 will be 1/2. 1 over 3, 1/3. 1 over 4, 1/4. 1 over 6, 1/6. 1 over 12. Oh, there it goes. Smartboard said I don't want your badge hanging in front of me here. That takes care of the 1. So now the 1 on the top, I've done everything I can do with that. And now I need to go to the 2. But I don't want to write anything down twice. That would be silly. So 2 over 1 is 2. I don't have that one down yet. But 2 over 2 is 1. It's already on my list. 2 over 3? No, that's not on my list yet. 2 over 4? Well, that's 1/2. Yeah, 1/2 is already up there. 2 over 6? That reduces to 1/3. 1/3 is already up there. 2 over 12 reduces to 1/6. 1/6 is already up there. So there's my list. There it is. So this is just about writing out all of those possibles, because like we found out, that helps us know whether or not our window is big enough so that we're actually seeing all the zeros that we're supposed to find. Which is, of course, where we're going next, because that's what we covered right after we did this. So rational root theorem led to finding zeros. Anybody need more time to get everything down? Alrighty. So like I said, we know what's coming. I mean, this is in the order we learned it. And 6 says, find all the zeros of the following function. And we go, duh, that's what we use that for. Zeros must be verified mathematically, so synthetic, and show your work for credit. So the first thing I do is I look at this and I ask myself, how many am I looking for anyway? How many zeros will this have? Google Meters, don't be afraid to help out. How many zeros will this have?
4.
It will have 4 because it's a degree 4 polynomial. Now, we don't know if our window will be good at negative 10 to 10, so we need to do what we just did, which is find all of the integer factors of the number that's in back. 20 has a lot of them too. I get them all? 1, 2, 4, 5, 10, 20? Yeah. Better news for the bottom. What number are we using for the bottom? So here's what that tells me. I'm not going to write all those as little fractions now. I really wanted to know how far out my zeros might show up, and that would be plus or minus 20 over plus or minus 1. We may have to make that window a little bit bigger, go from negative 20 to 20 so that we can see them, but that gives us a hint that if we don't see them all, and there's 4 of them, we have to make our window bigger. So at this point, you'd say, gosh, could I factor this? Is there any way to do this by hand? 1, 2, 3, 4, 5 terms? We don't know how to do 5 terms. So we grab the graphing calculator and we get that monster in. Y equals x to the 4th plus 3x to the 3rd. Oh, I did it again. I always forget I have to use my arrow key to get out. My older calculator doesn't make me do that. There. All right, again, we're handing it over to the calculator, so we need to double check. X to the 4th plus 3x to the 3rd plus x squared minus 12x minus 20. And I think I might actually go ahead and just change my window right now to like negative 25 to 25 to make sure I can see everything out to positive and negative 20. And hit graph. Looks like it only crosses twice, right? So if it only really crosses twice, what has to be true about the other 2 zeros? If we can't see them, they're not there. So what do we use to talk about the ones that are not there? We're going to have imaginaries. Absolutely. Well, I'm hopeful that those might be nice ones that show up in my table. Let's check. Ooh, it was way up in the numbers here. Just so everybody knows, there's a shortcut. If this ever happens to you, you can hit second window, and the number that pops up there, that says here's where we're going to start. So I could change that to 0. Now when I go back to my table, I won't be in la la land anymore. Well, good. 2, 0 and negative 2, 0. Excellent. So 2 pretty nice ones. I'm going to put GC negative 2 and 2. So what do we have to do, everybody, to work that down so we can find the last 2? Can't just stop. We only have 2 of them and we need 4. What do you want to do? Use a test-taking strategy. What is this test mostly about? Flip over to the front page. What did we do lots of? Aha! We're going to use synthetic to work this down to that last piece that we need. Doesn't matter if you do the 2 first or the -2. I'm just going to go according to the number line. I'd hit -2 first. 4, 3, 2, 1, 0. They're all there. Do your synthetic carefully. Remember, the math that we still have to do depends on it. Make sure you get that 0 over there. And again, I highly recommend the box for your remainder piece over there. Then go again. Because it works, we can keep going. So now we need to see what we have left. So we have x squared plus 3x plus 5. And we need to know where that equals 0. Now here's what we absolutely know. It's not factorable. Because any factorable ones show up on the graphing calculator. Those are our rational roots. And at this point, we said completing the square has been too long ago, and this one, in fact, would have fractions with completing the square. So it's a quadratic. It has a 2 right here. What works for solving any quadratic? What can we use to solve any quadratic other than completing the square? Hint, quadratic is in its name. The quadratic formula. Thank you. So A is 1, B is 3, and C is 5. And then we get the little song in our head. X equals -b. I don't have room for it. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So that's how we'll get the last 2. So we'll need the negative of 3 plus or minus the square root of 3 squared is 9 minus 4 times 1 times 5 all over 2 times 1, which is 2. And then we'll just have to simplify it. See if I can give myself some more space here. There we go. So now, either in your head or with a calculator, you figure out 4 times 1 times 5, that's 20. 9 minus 20 is -11. Aha! It is imaginary. We just have to figure out how to rewrite the square root of -11. So figure out how to simplify that, and I'll come back to you. The question is, what does the square root of, pardon me, cracking my voice here, the square root of -11 simplify to? I square roots of 11. Yeah, we've got square root of -11. That's the square root of -1 times the square root of 11. So you can either put I square roots of 11, or if it ends up being multiple choice, you're just going to look down and see. Maybe it'll say -3 plus or minus square root of 11I over 2. All right. Now on the practice test, I know there are only 7 problems. We're going to finish up the 7 here, but I have an 8th one that we're going to add to it that has very similar to number 7 here, very similar concepts. Because this is what we just talked about yesterday. The product of 3 consecutive integers. Ooh, there it is. That's from yesterday. The product of 3 consecutive integers is 1,716. Write the polynomial equation in factored form. Solve for the numbers. Then verify your answer synthetically. Again, if you're writing this down and you really want to write it down, only write the first sentence. The rest of it we're going to show with our work. All right, so here's the key, and I see a couple of people writing like crazy. So did you already remember what we have to do for our x's? Do you remember, Jane? Exactly. X plus 1, and x plus 2. Now, what does product mean? Multiply. So if we multiply all of those together, it has to equal 1,716. So there's the factored form. So like I said, you don't need to write down those instructions. To solve for the numbers, we know we had to multiply this out. So we did FOIL on those 2 little doggies first. Then we distributed the x. But we said, that's not calculator ready, because they said solve. And what do you have to have on one side of this equation whenever it says solve? Yeah, so we've got to subtract 1,716 from both sides. All right, everybody. We did this yesterday. Where do we go after this? Yep, graphing calculator. It has 4 terms. You could try factoring by grouping, but it's not going to work. Factoring by grouping is not going to happen. So good old GC. We have x to the 3rd plus 3x squared plus 2x minus 1,000, oops, forgot the minus, minus 1,716. Double checking. Okay, then what? Second table, so second graph. What are we looking for? A 0 in the y, okay? Don't see it yet, but it looks like it's getting closer. Ooh, there's one. So the first number is 11. What are the other 2? 12 and 13. They have to be consecutive integers, one right after another. Now we're almost done. We just have to check our answer. And when I say check our answer, what's the only number we check? Yes, because that's the one we saw in the calculator. So we're going to synthetically make sure we get a 0 using our numbers. And that way we'll be certain of our 11. I just wanted to show everybody that that's going to work. Oh, I'm not even on the right screen. Here we go. 11 times. Oh, that took so long, I forgot what it was. There it is. Okay, so those of you in the room that I gave the printout ones to, see if you have some space somewhere, because we need to add one more. And then this one, those of you that are in here, you're going to want to write it out. In fact, you could get away with just the first sentence right here. It is on the digital copy of the practice test. It's there too. But if you have it on there somewhere, then you won't have to flip back and forth between the digital copy. If you don't have any room, grab a piece of scratch paper, you know. The product of three consecutive integers is, wowzers, 681,120 more than their sum. Whew. Find the three consecutive integers. Google Meters, I'm just waiting until everybody has a chance to write it down. As you know, I have some people in the classroom, so that helps. I've got it labeled number 7. Isn't this really number 8? So here's what I'm going to tell you. We're going through 8 problems today. There's only 7 on the test. So one of these, you know, anything, I don't want to say anything that's repeated, because obviously we're going to repeat synthetic a lot as we go through this, but one of them you won't see. All right, are we ready? Bill. That's a good one. Okay. All righty, help me out here. Consecutive integers. We just did one like that, right? What do we use again? X plus 1, and x plus 2. Their product. Wait a second, we just did that too. Their product is, and is in math means equals, 681,120 more than their sum. What does sum mean? It does mean addition. So if we added them all together, it's still going to be 681,120 short. So we would have to add 681,120, which makes sense, especially if the numbers are big. You know, when you multiply them together, you're going to get something pretty huge. All right, so let's see. We already know what the left side is going to look like. We have to multiply the x plus 1 and the x plus 2, those two binomials together, and then distribute the x. But good news, the right-hand side is some pretty easy math, because all we have to do is combine like terms because it's addition. So x plus x plus x. 1 plus 2 is 3. 3 plus 681,120 is 681,123. Considering what we just did, is this calculator ready? No, because what do we want? We want a 0 on one side, so we are going to have to move some things over. We'll have to subtract 3x, and we'll have to subtract 681,123. are we calculator ready? Don't we also know these numbers are going to be pretty big, right? Because they have to multiply to 681,120. So this might take a little bit of scrolling before we can get there. So let's see. I'm going to leave that in there. X cubed plus 3x squared. Oops. Hit the wrong button. There we go. And I'm going to change that to minus an x and minus our 681,123. Double check. And now it's scrolling, scrolling, scrolling. Oh, we got lots of scrolling. Look at that. Those numbers are so small, they're using scientific notation. This is going to take a while. Well, at least it changed. Aha! Whew! 87 is the first number. So what's the next one? 88. And the last one. 89. Now, let's just we can check that. I mean, we know they're supposed to multiply together and give us something that is 681,120 more than their sum. So, let's go check. 87 times 88 times 89 gives me that. 87 plus 88 plus 89 gives me that. 681,384 minus 264. Ta-da! Got it. There it is. So 8 problems, 7 of which will show up with different numbers on the test tomorrow. And what I decided to do was to go through the entire practice test today so that tomorrow you can have time in class to work on the assignment and ask questions. If there's somebody in here that's missing the last test, tomorrow during class I'm going to have you take that test. So here is the assignment. It's 14 problems long, I think. Let me double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And don't forget to do this last one that talks about the consecutive integers. Make sure that you have that one on there. All right, Google Meters, you know the drill. If you have everything you need and you want to go off and work for a while, feel free to do that. We will be here for another 7 minutes or so if you run into some trouble. But don't forget to save something to work through tomorrow to get ready for the test on Thursday.
See you later. We'll
Yeah.
see you tomorrow.
Have a great day.
You too.
Thank you. All right.